Now, the next thing you need to be able to do is know about sine, cosine, and tangent ratios. Right? In any right-angled triangle, and that's all you deal with on this course, if that's the angle theta that I'm talking about, then that side over there is which side? That's the opposite. It lies opposite the angle. What's this one along here? Hypotenuse. Why is that? And this one is the adjacent. Now, if I'm doing Pythagoras' theorem, it doesn't matter which is the opposite and which is the adjacent. But if I'm talking about an angle, if that's the angle I'm talking about, what does that one have to be? The opposite. And then you can write down along your side Sohcahtoa. He was a famous Irish mathematician called Sohcahtoa. And from that you'll know that S, the sine, is OH is equal to the opposite over the hypotenuse. CAH, the cosine, is equal to the adjacent over the hypotenuse. And TOA, the tangent, is equal to the opposite over the adjacent. And every one of these triangles you solve, that's the first thing you'll write down along the side, Sohcahtoa. If Pythagoras' theorem doesn't work, then the only thing you have is Sohcahtoa. And Sohcahtoa will work. So let's look at a triangle and see can we write out the ratios. This is a fairly straightforward triangle. 6, 8, 10, and I'm talking about the angle A. If I'm talking about the angle A, what side is that? Yeah. Which side is this? So that leaves this to be the A. And if you write Sohcahtoa down along the side, it would say the sine is equal to the opposite over the hypotenuse. What's the opposite? 8. The sine of the angle A. And what's the hypotenuse? 10. What's the cosine of the angle A? It's the adjacent over the hypotenuse. What's the adjacent? Over 10. And what's the tan of the angle A? Opposite over the adjacent. What's the opposite? And the adjacent. So in any triangle, you can tell me what the sine, cos, and tan are. Right? Now, if I gave you this triangle, would you be able to tell me the sine, cos, and tan of theta? No. You'd have to find that missing side first. How would you find the missing side? Okay, so you'd use Pythagoras. And how would you find Pythagoras? The hypotenuse to be squared is the length to be squared plus the adjacent to be squared. And when does this work? When it's a right angle triangle, you're given two sides, and you want the third side. What's the hypotenuse? Root 5 to be squared. The opposite? 1 to be squared, plus the adjacent to be squared. Root 5 to be squared is equal to 1 plus the length of the adjacent to be squared. Bring the 1 over. 5 minus 1 is the length of the adjacent to be squared. Did I hear 6 spoken? I did. Do you understand why it is not 6? 5 minus 1. 4 is the length of the adjacent to be squared. So the square root of 4 is the length of the adjacent. 2 is equal to the adjacent. So I now know that to be 2. Yes? And when you're talking about an angle, you name your sides. What side? Opposite. Side, hypotenuse, side, adjacent. Would they be the same if I was talking about this angle? No. Which one never changes? And when I do that, I can now write down Sohcahtoa. In Sohcahtoa, the sine is equal to the opposite over the hypotenuse, SOH. The sine of my angle theta is, what's the opposite? 1 over root 5. The cosine is the adjacent over the hypotenuse. The cosine of my angle theta is the adjacent over root 5. And the tan is equal to the opposite over the adjacent. So that means that the tan of theta is equal to 1 over 2. Any questions? Yes. When you go to the angle you're talking about, and the one that's straight opposite it is called this one, so the other one has to be. So when you're talking about an angle, what one can you name first? Then you can name, and the other one is the, and the adjacent is the one that's alongside it. It's by the side of the angle. Is that clear now? Do you understand that? All right. Now, look at this, and this is important, so it is. If you were able to do this, it would be the first bit of maths you'd really have today. If I told you that the tan of some angle A is equal to 3/4, would you be able to tell me the sine of A and the cosine of A? You would? Well, tell me. Alright, perfect. Sohcahtoa. I know that the tan of the angle A is equal to what? The opposite over the adjacent. So if the tan is 3 over 4, that means what? That the opposite must be 3. And that the adjacent has to be 4. So now I would draw my right angled triangle. And if this is the angle A, which side is the opposite? There. So that's 3, because it's the opposite. Which side is that? 4. Why? It's the adjacent. I don't know the other side. Pythagoras is here, given 2 sides. The length of the hypotenuse to be squared is the length of the opposite to be squared plus the length of the adjacent to be squared. Hypotenuse to be squared is equal to 3 squared plus 4 squared, which is 9 plus 16, which is 25. So that means the length of the hypotenuse is what? Square root of 25, which is 5. So I now know that that's 5. So now you can tell me the sine of A. What's the sine? Opposite over the hypotenuse. SOH. Opposite? 3 over 5. Cosine of A? adjacent over hypotenuse, which is 4 over 5. Now, if you don't understand that, I'd like you to speak. The cosine of some angle B is equal to 2 over root 5. I want to know what's the sine of B and what's the tan of B. What will I write down along the side? Why Sohcahtoa? There's nothing else. That's all, these will all be the Sohcahtoa. I have the cosine of B. Cosine is what? Adjacent over hypotenuse. So in this triangle, what do I know the adjacent to be? 2. And what do I know the hypotenuse to be? And if I draw that in a triangle, this is root 5. That line is what line? The opposite. So this one is the adjacent. And that one, of course, was the height. What's the adjacent? 2. How would you find the opposite? And it says the length of the hypotenuse to be squared is equal to the length of the opposite to be squared plus the length of the adjacent to be squared. Fill it in. Hypotenuse to be squared, root 5 to be squared is equal to the opposite to be squared, plus the adjacent, 2 to be squared. Root 5 to be squared is the length of the opposite to be squared plus 4. 5 minus 4 is the length of the opposite to be squared. 1 is equal to the length of the opposite to be squared. The square root of 1 is equal to the length of the opposite. 1 is the opposite. So what could you tell me here now? Okay. Just let's get it right. Sin is for the religion department. For us it's sine. Sounds much better. And for short we write down SIN. But we never call it that. Sine is equal to the opposite over the hypotenuse. Opposite, 1 over root 5. And the cosine, we know that the tan of the angle B would be what? Opposite over the adjacent. And in this case it's what?